ourselves Team Rayo, which means lightning bolt. And I will now talk about the challenges that we worked on. So the first one was the challenge zero, that is setting up TFS on a local virtual machine. And the second one is challenge one, that is the Ansible automation of micro Kubernetes deployment. And the third challenge is we take L2 VPN, which actually is designed to behave as a slice, and then we redefine it to behave as a service. And this is us. Okay, so the first thing is, so we install VirtualBox on the host server, a laptop, and then if you look at the link like we've shared here, it contains all the requisites and instructions to install the micro Kubernetes and TFS. So when you follow that, so the first thing is you install the packages, the like curl, JQ, snapd, and then Docker, and then micro Kubernetes, and then finally TFS. So when you're trying to install, you'll find certain errors like this. So I mean, we can solve that by running these commands like usermod, chown, change ownership, and also like by installing micro Kubernetes, uh, and then you can verify it has been installed by running the kubectl get all, and um, and these are the other like when you install micro Kubernetes, you also have to enable other packages, so like DNS, ingress, registry, and yeah, and this is the TFS installation part as well. And then this is TFS being installed, and yeah. And then so the second challenge we worked on is the Ansible-based automation. That is, so the goal is instead of running these commands manually, like how we saw in challenge zero, well, why not have an Ansible playbook, which you run that Ansible playbook once and then it installs micro Kubernetes in your system. You could ask, like, why can't we do this by deploying a shell script instead of an Ansible playbook? Well, if it's running on just one node, a shell script also can do the job, but Ansible's main value, its selling point, is that it's a push-based automated configuration software. So if you want to install micro Kubernetes simultaneously in many servers, Ansible is a good tool to use. But in this Hackfest, we're just using Ansible to um, install micro Kubernetes on one system, that is just the master node, that is where Ansible is installed. And so in order to do this, so first we need to install Ansible on the server. So that's very simple. You just need to run these two commands, sudo apt update and sudo apt install Ansible. And once that is done, we can verify if Ansible has been installed by executing the command Ansible hyphen version. And also we can verify if it's able to ping itself successfully, like Ansible localhost hyphen and ping. And if there are many slave nodes attached to the Ansible master node, you can verify that they are connect. Ansible has access to them by by saying ping all, so it will ping itself and the slave nodes as well. But in this context, we do not have these slave nodes. It's just the Ansible master node. And so for that, you need to first make a playbook. The playbook usually starts off as like name, install micro Kubernetes on Ubuntu server, local host because itself, that is the master what kind of micro Kubernetes. So we have like the channel 1.29 stable and the tasks, like the things you need to do in order to install Ansible first and update cache and install Docker and all these other packages. And this is a portion of the what once Ansible is installed, this you wait for it to get ready. Basically, what we did is we took the manual commands and then we created an Ansible playbook that is a YAML file. And if you like, you use and you see shell. Shell is actually the command being executed, like name shell, and then these are other contexts like retries, like try 10 times if it doesn't work, and then that's how we wrote the playbook. That's basically a YAML file. And then configuring the Docker daemon, then restarting Docker, all these things are mentioned in the YAML file. So once the YAML file is made, we execute the Ansible playbook, and then it starts installing all the packages and micro Kubernetes resource like from scratch. And this is the process that you see in the logs. And then finally, when everything is done, you get this final message over here that Ansible has been, micro Kubernetes has been installed. So that is the end of challenge one. And then the last challenge we worked on was redefining the L2 VPN. So the problem statement was the L2 VPN in TFS. That is the TFS has many microservices. Microservice that we are looking at specifically is the pod called NBI. So in that, the L2 VPN is defined as a slice, as a network slice. In this problem, we have been asked to redefine it as a service. So what we're going to do is follow the instructions given. We will analyze how L2 VPN works. We will analyze how the L3 VPN also works. And so that's the strategy. So inspect the source code of L2 VPN, inspect the source code of L3 VPN. So then by looking at L3 VPN, we will like get an idea or inspiration, insight on how to redefine the L2 VPN. And the goal is so the NBI pod, which is one of the most is one of the pods that make up TFS. When you deploy the L2 VPN, it talks to the service pod. It talks to the slice pod because it's defined as a network slice. But what we want to do is we want to make it talk to the service pod so it can be deployed as a service instead of a slice. So now that we have the high level definition of the problem, now we will dig into how to implement this technically. And we will also not use Yang validator because which I'll explain later down this presentation. So now let's look at the L2 VPN. You can find this at the source code at the link that we shared here. And if you see here, there's three main files that's responsible for this. That is the L2 VPN service, L2 VPN services, and the network accesses. So once you look into the source code of the file, like you can see, like how it says like the target gets sliced by UUID and context client. So context client, I would say, is one of the most fundamental, important microservices of TFS. So NBI has to talk to the context via the context client. That's the instance of the gRPC client of which talks to the context to the gRPC server in the context microservice. That is the gRPC server in the context microservice is the NBI of the context pod. And it's from what we analyzed, it's a very fundamental component to the functioning of TFS. And if you see here in the services.py of L2 VPN, it says slice request equals slice, which I've highlighted. So what that means is we're creating an instance of a slice class, which is the main reason why the L2 VPN is being instantiated as a slice. So this helps us get insights into how the L2 VPN is deployed from the source code. And it's imported from the protobuf from the file of the slice pod. And also, this is from the network accesses. We have these definite like process site network access. That's to you need to know that you need to be able to access the network in order to deploy the VPN in that network. And then we have the details of the network, like router ID. I think these are like fundamental properties of all these network elements in a network. And process list site network. And now we'll look at the L3 VPN. So we see some similarities between the L2 VPN and the L3 VPN. That is, we have L3 VPN service, we have L3 VPN services and site network accesses, similar to how we had it in L2 VPN as well. And if you so again, even the L3 VPN talks to the context pod. So as I was mentioning, the context pod is important. And as you see here, if you see so you see something called service client in the try. So what it does is it instantiates it as a service instead of a slice, um, which is which is what we want to do for this is the put method. So there's to update the L3 VPN request data, and you see it's as a service, not as a slice. And this is the L3 VPN services.py Python file. It's like it's a where the definition the like to post the L3 VPN is mentioned here, and the processing the L3 VPN and this and the network accesses as well for the L3 VPN. So what we understand is now that we got the skeletal structure of how an L3 of how a service is for the L3 VPN, we need to modify the skeletal structure of the L2 VPN to match the skeletal structure of the L3 VPN, which is as a service. So we need to redefine it from slice to service. So the changes we made is so here it stays almost pretty much the same. Like we talked to the context plane, but instead of slice ready status or slice status, we rebrand it into service, and then we instantiate for a service status which is like similar to how it was for the L3 VPN instead of a slice. And if you look at if you look at service L2 VPN services.py, the new modified one, you see service request equals service. Initially, in the first one, what we saw in the L2 VPN, it was slice request and slice, and then you also had get instead of like you get like the content by slice, now you're getting it by by service ID instead of slice ID. So that's like the main changes we made for the L2 VPN. And then most of the processing of the site network accesses, most of it stays the same, except changes in instead of slice, we reference to the service uh, packages, and yeah, these mostly stay the same. But now it's the context is now it has to be instantiated as a service instead of slice. And now we have to test the changes. So once these changes have been made, so we need to verify that it works. So we need to run a Python a unit test, which is also available from the Teraflow controller. So first we upload the topology um, into the Etsy via the web UI into the TFS controller, and then we go to this location dot slash scripts untest locally NBI all dot sh. So what we did was we removed all the other tests and we only kept the tests for NBI all for L2 VPN because there's many things that the NBI does, but we only ran the test for the L2 VPN. So after changing the files, those main three files in the L2 VPN folder in the TFS repo, and then you'll see things like this. And then finally, when it's done, you'll see like, okay, when everything is done, you get all these things that connectors registered, completed. So this proves that if we can, um, I don't, I can have it because it's a unit test. It's not actually running, but it's a it's mimicking instantiating the L2 VPN as a service. So I think I can confidently say it's being instantiated as a service instead of a slice. Now I'll stop presenting and Hubert will take over to give a small demo on how it is
Sure.
of running the test. So
Great.
we can see it being
Thank you.
instantiated as a service. Yeah.
Okay, thank you, Alan. I will have like a 1-2 minute demo. So first, just want to go and share this the file with you where we upload the new L2 VPN. So if you go there in the Hackfest 8, normally you can have both folder here, and then in the yes, L2 VPN and then iteration, or maybe directly here up you can see it that we have new slides. I mean the three modified slide. I mean the three new updates. You can see directly that we now having like the slicing, but we now speaking about services since we plan to have like a service instance instead of slicing. So same with the services. You can check here directly and see that now we are doing some request directly on services instead of slicing. So everywhere where was there was in the current, I mean the old version L2 VPN versions. Now we do have like services. So even if I'm going back a bit on the Ansible notebook we deployed to install the Kubernetes micro Kubernetes, so you can see the note playbook here with all the detailed information. So all that you can see directly in our folder here. So let's go now and start our demo. So we want now to check if the update went right. So if everything was good. So let me go to the first control and then check the script. So the script name here is the run test. Yeah, then we have
No.
locally.
First scripts and no, go back. Do cd dot dot. Go back. Cd
Yes.
dot 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 slash scripts
Mm, okay.
dot slash scripts because only then it will be able to access the other packages dot slash scripts.
Okay, good. Okay. But even I think it's also working. I try it also get and
Run
run. Yes.
MBI
Yeah.
MBI all.
Well, yes.
Yes.
So we are trying now to check all the updates. So during the running time, we can also see if there is any issues or error happening during the yes. Okay. So what you can see here is it's still running. So
And then you can also show them that we changed the files inside the TFS controller as well for the L2 VPN.
yeah, I already show it. So it's here. So we have this 1, 2, 3 slide. I
No,
mean
no,
five.
inside the TFS control, like like below snap, TFS control.
Mm, okay.
No, go down. No, no, snap. Below snap,
Yes,
you see
sure.
TFS
Yes.
control. No, click on TFS control. Down. Just
Oh no,
double,
yes.
no,
Sure.
just go down. SRC. No, not hack for state, go down. SRC. Yeah, and then MBI. and then you see the service
Mm.
and
Yes.
IETF L2 VPN. So we changed the files here as well, and then we
Yes.
restarted the micro Kubernetes, and that basically we redeployed TFS. So the changes we made takes effect before running the unit test for NBI. So as you can
Mm.
see, it's running successfully. So I mean, I think this is a good sign that what we did is correct, and we're deploying L2 VPN as a service now instead of as a
Sure.
slice.
Yeah, I mean, you can also see that all L2 VPN test passed here, 6 at least, actually. And also that even the L3 VPN also, I mean, the new versions went also white without any issues. So means like the update went successful. So yes.
Yes, you can see in the like get service passed the test. So the L2 VPN get service passed,
Mm,
which means like it's successfully deploying as a service now. So this is what we were working on, and yes, thank you
great.
everybody. Thank you,
Thank you.
Luis, for your guidance and help.